Spark Fundamentals on Spark over Kubernetes. Spark Fundamentals on Spark over Kubernetes. A simple guide. Imagine you have a big task to do, like sorting a huge pile of photos. Doing it all alone would take forever, but if you had friends to help, you could finish much faster. Spark on Kubernetes is like having a team of friends to help you process big data. Kubernetes is like the team leader who makes sure everyone has the right tools and works together smoothly. Here's a breakdown of how it works. 1. Spark applications. Think of your big data task as a Spark application. It tells Spark what to do with the data, like sorting photos by date or finding the most popular ones. 2. Spark architecture, Spark driver. This is like the team leader who tells everyone what to do. It manages the overall process and makes sure everything runs smoothly. Spark executors. These are your friends who actually do the work. Each executor gets a piece of the data to process, like sorting a batch of photos. Kubernetes pods. Each executor runs inside a pod, which is like a small container with everything it needs to run. Kubernetes manages these pods, making sure they are running and ready to work. 3. Deployment models. Standalone mode. This is like working on your own without any help. It's simple but not very powerful. Yarn mode. This is like working with a team in a large company. Yarn, yet another resource negotiator, is a resource management system that helps allocate resources and coordinate work. Kubernetes mode. This is like the best way to work, having a powerful team leader Kubernetes, and specialized workers pods to help you complete the task efficiently. 4. Resource management. Dynamic allocation. Kubernetes can automatically adjust how many workers pods are used based on how much data you have. If the workload is big, it adds more workers. If it's small, it uses fewer. Pod management. Kubernetes keeps track of all the pods and makes sure they are working correctly. If one pod fails, it creates a new one to take its place. Cluster configuration. Kubernetes can be configured to use resources efficiently, making sure everyone has what they need without wasting anything. 5. Advantages. Scalability and elasticity. Spark on Kubernetes can easily scale up or down based on your needs, just like adding more friends to the team when you need more help. Resource optimization. Kubernetes makes sure everyone has the right tools and resources, so you don't waste any time or effort. Containerization. Using pods makes your application easy to move and run on different computers, just like packing all your tools in a portable box. 6. Considerations. Network configuration. Make sure that all the components of your Spark application can talk to each other properly, just like your team needs to communicate effectively. Security. You need to protect your data and applications, just like you wouldn't leave your photos lying around for anyone to see. Monitoring and logging. You need to keep an eye on how everything is working and be able to fix any problems that arise, just like you need to check if everyone is doing their job correctly. In simple terms, Spark on Kubernetes gives you a powerful, flexible, and efficient way to handle large data tasks. Imagine your friends working together in a well-organized team to help you finish your photo sorting project. That's what Spark on Kubernetes is all about. Provides scalable and elastic Spark execution environment. Imagine you have a bunch of tasks to do, like analyzing a huge pile of data. Sometimes you need a lot of power to get things done quickly, but other times you only need a little bit. Spark on Kubernetes lets you adjust the power you have available on the fly. It's like having a team of workers who can join in when you need them, and leave when you're done. Scalable. You can easily add more workers, like adding more people to your team if your tasks are getting bigger and more complex. Elastic. The number of workers can go up and down depending on the load. It's like having a team that grows and shrinks as needed, making sure you have just the right amount of power for the job. Let's say you are analyzing customer data. During peak hours, there's a lot of data coming in, so you need a bigger team of workers, more resources, to handle it. But during slow hours, you don't need as many workers, so you can reduce them to save money. Spark on Kubernetes lets you adjust the size of your worker team automatically, so you only use the resources you need when you need them. This makes your analysis faster, more efficient, and cheaper.
Enables resource management and optimization. Imagine you have a big project like building a house. You need different tools and materials, right? And you want to use them in the best way possible to get the job done efficiently. That's kind of like what enables resource management and optimization means for Spark on Kubernetes. Spark on Kubernetes is like a super efficient construction crew. Kubernetes helps manage the tools and resources, like workers, computers, and memory, that Spark needs to run its tasks. This management ensures everything is used effectively and avoids wasting any resources. Think of it like this. Resource management. Kubernetes helps organize the tools, like workers, memory, and storage, and assigns them to the right tasks. It's like the construction manager who knows which worker to use for each job, making sure everyone is busy and efficient. Optimization. Kubernetes finds the best way to use those resources, like ensuring tasks are done quickly and minimizing any waiting time. It's like the manager finding the most efficient way to move materials around the construction site so there are no bottlenecks. This way, Spark can run smoothly and efficiently, using only the resources it needs. It's like having a well-organized construction site where everyone works together effectively to complete the project on time and with minimal waste.
Overview of Spark's architecture on Kubernetes. Imagine you have a big task to complete, like building a house. You need different teams of workers like carpenters, plumbers, electricians, to do different parts of the job. Spark on Kubernetes works the same way. It breaks down a big data processing job into smaller tasks and then distributes these tasks to different workers. Let's explore how this works. Spark applications. Think of these like the blueprints for your house. They tell Spark what to do with the data. In Kubernetes, these applications are packaged as pods, like individual containers for the workers. Spark driver. This is like the foreman on the construction site. It receives the blueprints, Spark application, oversees the entire job, and manages the work of the other workers. It's like the brain of the operation, coordinating all the tasks, Spark executors. These are the individual teams of workers like the carpenters, plumbers, and electricians. They each handle a specific part of the data processing job. They run on separate nodes like individual computers in the Kubernetes cluster. Example, let's say you want to analyze customer purchase data to find trends. 1. Your Spark application would be the instructions on how to analyze the data, like finding the most popular products or identifying customer groups. 2. The Spark driver would receive these instructions and coordinate the whole process. 3. Spark executors would each work on a piece of the data, like analyzing a specific month's purchases or looking at purchases from a certain region. This distribution of work makes Spark very efficient. By assigning tasks to different workers, it can process data much faster than doing it all on a single computer. And since Kubernetes manages the deployment and resources, you don't have to worry about finding and configuring all the computers yourself.
Spark applications run as Kubernetes pods. Okay, let's break down how Spark applications live inside Kubernetes. Using the familiar image of a pod, imagine you have a really big job to do, like baking a cake. You need all sorts of tools and ingredients, right? A Spark application is like that big baking job. It needs different parts to work. Kubernetes is like your kitchen. It provides the space and resources for you to bake. A Kubernetes pod is like a dedicated workspace within your kitchen. It holds all the tools and ingredients needed for one specific task, in this case, running a Spark application. Each Spark application gets its own pod. Inside that pod, you'll find Spark driver. Think of this as your recipe book. It tells the whole application how to run, what ingredients, data to use, and what steps to take. Spark executors. These are like your kitchen helpers. They are the ones who actually do the baking work, processing data based on the recipe. Each pod can have multiple executors working in parallel, like having several ovens and mixers. Here's a simple example. Imagine you have a recipe to make a chocolate cake. Your Spark application is the whole recipe. The pod is your kitchen counter, and you have the Spark driver. This is your recipe book, holding all the instructions for making the chocolate cake. Spark executors. These are your kitchen helpers, like a mixer and an oven. They follow the recipe to mix the ingredients and bake the cake. Key takeaway. By using pods, Kubernetes keeps each Spark application isolated and independent. It's like having separate counters for each recipe you want to bake. This allows you to run multiple Spark applications at the same time without them interfering with each other.
Spark driver manages the execution of Spark jobs. Imagine you're building a house. You have the blueprints, your Spark application code, and the materials, your data. Now you need someone to oversee the entire construction process, making sure everything is built correctly and on time. That's the role of the Spark driver. The Spark driver is like the project manager for your Spark job. It's responsible for reading your Spark application code. The driver understands what tasks your application wants to perform on your data. Dividing the work into smaller chunks, it breaks your big job into smaller, manageable pieces called tasks. Assigning tasks to workers. The driver sends these tasks to the Spark executors, which are like the individual construction workers. Coordinating the workers. It keeps track of which workers are doing what and ensures they communicate with each other smoothly. Collecting the results. Once all the tasks are finished, the driver gathers the final results and presents them to you. Example: let's say you want to calculate the average age of all customers in your database. Your Spark application tells the driver to do this. The driver then divides the task of analyzing each customer's age into smaller tasks, sends these tasks to different executors, and collects the results from each worker to calculate the final average age. So, the Spark driver is the heart of your Spark job. It manages the entire execution process, making sure everything runs smoothly and efficiently to get your desired result.
Spark executors run tasks on worker nodes. Imagine you have a big task to complete, like building a house. You can't do it all by yourself, so you need a team of workers to help. Each worker has their own set of tools and skills. In Spark, it's similar. Spark has executors, which are like the workers. They are responsible for actually doing the work, the tasks, needed to run your Spark program. These tasks could be anything like analyzing data, performing calculations, or generating reports. Now, these executors don't work alone. They need a place to work, which is where worker nodes come in. Think of a worker node as a computer that's specifically set up to run Spark. So when you launch a Spark job, each executor is assigned to a specific worker node. On that worker node, the executor has access to all the resources it needs, like memory, CPU, and storage, to complete its tasks. For example, let's say you're analyzing a dataset of customer purchases. Your Spark program might be divided into many tasks, like calculating the average purchase amount, identifying the most popular products, or grouping customers by their buying habits. Each executor might be responsible for one or more of these tasks. They work independently on their assigned worker nodes to get their part of the job done. Once all the executors finish their tasks, the results are combined, and you get the final output from your Spark job.
Spark application deployment. Okay, let's talk about deploying Spark applications, which is like setting up your Spark program to run on your computer, but in this case it's a bit more complex because we're using Kubernetes. Imagine you have a big project like building a house. You need different tools and workers for each step. Spark is like the project manager, and it needs different workers, called executors, to do specific tasks. To make everything work smoothly, we need to figure out where to put these workers and how to organize them. There are three main ways to deploy your Spark application. 1. Standalone mode. Think of this like having your own little workshop. You set up everything yourself, your tools, your workspace, everything. In this mode, Spark runs directly on a single computer, so you have complete control. It's simple for small projects, but if your project gets big, you'll need more workers, and that can get complicated. 2. Yarn mode. Now imagine you have a bigger project and need to borrow tools and workspace from a shared facility. That's what Yarn, yet another resource negotiator, is like. It's a resource management system that allows different programs to share the same resources. Like computers and memory, Spark can use Yarn to get resources from a cluster, a group of computers, and run its workers there. This is good for bigger projects, but you need to know how Yarn works. 3. Kubernetes mode. Now let's imagine a big construction company with a team of specialized workers. Kubernetes is like that company. It's a system that manages containers, like little boxes that hold your tools and software. Spark uses Kubernetes to deploy its workers as containers. This makes everything easier to organize, scale, and manage. It's like having a dedicated team for your project. Example: let's say you have a Spark program to analyze a big dataset of customer reviews. In standalone mode, your Spark program runs on your laptop. It's simple but limited. Your laptop might not have enough power for a big dataset. In Yarn mode, your Spark program uses a cluster of computers provided by a company. You have access to more power, but you need to learn how to use Yarn. In Kubernetes mode, your Spark program is deployed as containers on Kubernetes. This gives you flexibility, scalability, and easy management, like having a powerful and organized team to tackle your customer review analysis. In summary, standalone mode is good for small projects. Yarn mode is good for medium to large projects that need to share resources. Kubernetes mode is the most flexible and powerful option for large projects, especially if you want to scale up and down easily.
Deployment models, Spark deployment models. Picking the right way to run your Spark jobs. When you want to use Spark to process big data, you need a way to set up your Spark environment. This is where deployment models come in. Think of them like different ways to build a house for your Spark application. Each model has its own strengths and weaknesses. Here are the main deployment models you'll encounter. 1. Standalone mode, the basic setup. Imagine you have a single computer and want to run Spark on it. This is the simplest model. How it works: Spark runs directly on the computer, managing all the resources itself. It's like having a single room in your house where everything happens. Good for small projects or testing things out. Example: you're just starting out and want to try Spark without the complexity of a full cluster. 2. Yarn mode, sharing the resources. Imagine you have a big building with many rooms. You need to share the rooms with other applications, but you still want to run Spark efficiently. How it works: Spark uses Hadoop's Yarn, yet another resource negotiator, to request and manage resources within a larger cluster. It's like asking the building manager for rooms to run your Spark jobs. good for larger projects that need to share resources with other applications. Example, your company has a large Hadoop cluster, and you want to use Spark alongside other Hadoop applications. 3. Kubernetes mode, containers for flexibility. Imagine you have many small independent containers, each designed for a specific purpose. These containers can be easily moved and scaled as needed. How it works. Spark runs in containers managed by Kubernetes. This gives you a highly flexible, scalable environment where you can easily deploy and manage Spark jobs. Good for large, complex projects that need to scale quickly and efficiently. You can easily add or remove containers depending on your needs. Example, your company needs a highly scalable data processing pipeline that can handle fluctuating workloads. Kubernetes allows you to add more containers and therefore processing power as needed. In a nutshell, standalone mode, simple but limited to a single machine. Yarn mode, good for sharing resources within a Hadoop cluster. Kubernetes mode, highly flexible, scalable, and well-suited for large-scale deployments. Choosing the right deployment model depends on the size and complexity of your project, your infrastructure, and your specific needs.
Standalone mode. Imagine you have a simple computer, like a laptop, and you want to run a program on it. That's kind of like standalone mode in Spark. It's the simplest way to run a Spark program, where everything happens on one single machine. Think of Spark like a group of workers. Each worker has a job to do, and they work together to finish a bigger task. In standalone mode, all these workers are on your single machine, like a team working in a single room. Here's how it works. One machine, one team. You have one machine that acts as the boss, the Spark master. This machine tells all the workers what to do. Workers on the same machine. All the workers, called Spark executors, are also on the same machine. They receive instructions from the boss and work together to finish the job. Simple and easy. Standalone mode is very easy to set up. It's great for learning Spark or for small projects where you don't need a lot of power. Example, let's say you want to analyze data from a website. You have a laptop and you set up Spark on it. You tell Spark to analyze the website data, and all the Spark workers on your laptop get to work. Since everything is on one machine, it's a simple process. Limitations, limited resources. Standalone mode only uses the resources of your single machine. If your machine is not powerful enough, your Spark job might be slow. No scaling. If you need to handle a lot of data or if your job needs more computing power, you can't easily scale standalone mode by adding more machines. You'd need a different way to run Spark, like Yarn mode or Kubernetes mode. In short, standalone mode is a good starting point for learning Spark or for small projects, but it's not the best choice for large-scale applications or when you need to use more than one machine.
runs Spark on a single node. Imagine you have a computer, like your own laptop. Now, think of Spark as a program you want to run on this computer. When you choose standalone mode, it's like running Spark directly on your single computer. Think of your computer as a node, a single point where everything happens. In this mode, Spark doesn't need to share resources with other programs. It gets to use all the power of your computer, making it perfect for smaller tasks or for learning how Spark works. For example, let's say you want to analyze a small dataset about your friends' birthdays. You could install Spark on your computer and use standalone mode to process the data quickly. You wouldn't need a big, powerful server farm. Your computer would be enough.
To uses Yarn for resource management. Imagine you have a big task to do, like building a house. You need different tools and workers to get it done. Yarn, yet another resource negotiator, is like a manager for your tools and workers. In the world of Spark, Yarn helps manage the resources needed to run your Spark jobs. It acts like a central hub that allocates the right amount of computing power, like the number of workers, and memory, like the space for storing tools to your Spark applications. Think of it like this. Spark application, this is your house building project. Yarn, this is your manager who decides which workers, computers, and tools, resources are needed for the project. Workers, these are the individual computers that handle the actual work of your application. Tools, these are the resources like memory and CPU that the workers need to do their jobs. Yarn makes sure that each Spark application gets the right amount of resources, preventing one application from hogging all the available resources and slowing down others. It helps ensure that everyone gets a fair share, so your projects can run smoothly and efficiently.
Kubernetes mode, Spark on Kubernetes. The Kubernetes mode, imagine you have a powerful toolbox for building and running your projects. Spark is like a great tool in this toolbox, perfect for analyzing large amounts of data. Kubernetes is another powerful tool, a master organizer that manages your projects, making sure they have the right resources and run smoothly. Kubernetes mode is about combining these two tools, Spark and Kubernetes, to create a super efficient data analysis system. It's like having a team of experts working together. Spark does the heavy lifting of crunching data, and Kubernetes makes sure everything runs smoothly and efficiently. Here's how it works. Spark applications as pods. In Kubernetes, everything runs in containers like little self-contained packages. Spark applications are also put into these containers, called pods. Think of it as a little house for each Spark application, providing it with everything it needs to run. Spark Driver as a pod. The Spark Driver, the main coordinator of the data analysis process, also lives in its own pod. It's like a project manager directing the work of other Spark components. Spark Executors as pods. The Spark Executors, which actually do the calculations on the data, are also housed in their own pods. These are like individual workers, each processing a piece of the data. How it's useful. 1. Scalability. Kubernetes makes it easy to scale up your Spark applications. Need more computing power? Just add more pods, like adding more workers to your team. Need less? Remove some pods. 2. Resource management. Kubernetes manages the resources like computer power and memory for your Spark applications, ensuring each pod gets what it needs. It's like a smart organizer, making sure everyone gets the right amount of space to work. 3. Flexibility. Kubernetes lets you run your Spark applications on different types of machines, from your own servers to cloud providers. It's like having a toolbox that works anywhere. Example. Imagine you want to analyze customer data to understand buying trends. You create a Spark application to do this. Kubernetes puts this application into a pod along with the Spark driver and executors. Kubernetes manages the resources for this pod, making sure it has enough computing power and memory to handle the analysis. As your customer data grows, Kubernetes automatically scales your application by adding more pods, giving you more computing power to analyze the data. In simple terms, Kubernetes mode brings the power of Kubernetes to Spark, making it easier to manage, scale, and run your data analysis applications.
Leverages Kubernetes for containerized execution. Imagine you have a big task like building a house. You need different teams of workers, each with their own tools and supplies, to do different parts of the job. Now imagine that each team works inside its own small portable building. A container. Kubernetes is like a manager who helps organize all these containers and their workers. It assigns each container to a specific place, like a room in the house, and makes sure they have the resources they need, like electricity and internet. Spark, which is like the main contractor overseeing the house building project, uses Kubernetes to manage the containers where its workers run. Here's how it works. 1. Spark applications. These are like the blueprints for the house, telling Spark what needs to be done. 2. Kubernetes pods. These are like the small buildings, containers where each team Spark worker works. Kubernetes manages these pods, deciding where to put them, how many to use, and what resources they need. 3. Spark driver. This is like the project manager who looks at the blueprints and tells the workers what to do. 4. Spark executors. These are the actual workers who do the tasks. Each executor works inside a Kubernetes pod, completing their assigned jobs. So, by using Kubernetes, Spark can easily create and manage pods for its workers, ensuring they have the right resources and are organized efficiently. It's like having a dedicated team for each part of the house construction project, all working together smoothly under Kubernetes' guidance.
Resource management in Spark on Kubernetes. Managing resources like a pro. Spark on Kubernetes. Imagine you're building a house. You need to carefully manage the materials like wood, bricks, and concrete to build it strong and efficient. Similarly, when running Spark applications on Kubernetes, you need to manage resources like memory, CPU, and storage wisely. Kubernetes acts like a smart manager for your Spark applications. It helps you, 1. Dynamically allocate resources. Think of this like a flexible supply of materials for your house. With dynamic allocation, Kubernetes adjusts the resources given to your Spark applications based on their workload needs. Example: if your Spark application is processing a small amount of data, Kubernetes might give it less memory and CPU. But if the application needs to process a massive amount of data, Kubernetes will automatically increase the resources to handle the workload. 2. Manage Spark pods. Pods are like individual rooms in your house where the actual Spark work happens. Kubernetes makes sure the right number of pods are running, and they have the resources they need to perform their tasks efficiently. Example: if your application needs more workers to process data quickly, Kubernetes will create more pods to handle the workload. If the workload reduces, Kubernetes will automatically shut down some pods to avoid wasting resources. 3. Configure the Spark cluster for efficiency. Kubernetes lets you tweak the settings of your Spark cluster for optimal resource use. It's like customizing your house for the best comfort and efficiency. Example: you can set the number of executors, worker pods, in your Spark cluster, how much memory each executor should have, and how many cores they should use. This allows you to fine-tune the cluster for your specific needs. By managing these resources effectively, you can ensure your Spark applications run smoothly and efficiently on Kubernetes. This allows you to get the most out of your computing resources while saving money and improving performance. Introduction to Spark on Kubernetes. Imagine you have a powerful tool for analyzing huge amounts of data, like a giant spreadsheet with billions of rows. This tool is called Spark, and it's fantastic for crunching numbers, finding patterns, and getting insights from your data. Now imagine running Spark on a group of computers working together like a team. That's where Kubernetes comes in. It's like a super organized manager that makes sure all the computers in the group are working efficiently and smoothly. Think of Kubernetes like a city manager. It manages the traffic, ensures everyone has enough space and resources, and makes sure the city, your data processing, runs smoothly. Here's how Spark on Kubernetes works. Spark is like a team of workers. Each worker has its own task to do, like calculating a specific part of the data analysis. Kubernetes is the team leader. It tells the workers where to go, what to do, and makes sure they have everything they need to get the job done. Kubernetes allows the team to grow or shrink depending on the workload. If the data analysis is simple, Kubernetes will use fewer workers. If it's complex, Kubernetes will add more workers to speed things up. Let's break it down with an example. Imagine you want to analyze millions of customer reviews to understand what people like and dislike about a product. Spark is the analysis tool. It reads the customer reviews, processes the data, and creates a summary of what people are saying. Kubernetes manages the processing. It ensures that the different tasks are distributed to multiple computers, making the process faster and more efficient. If the analysis needs more power, Kubernetes adds more computers to the team. This helps Spark process the data faster and generate insights more quickly. By combining Spark's data processing power with Kubernetes management skills, you can analyze huge datasets datasets quickly and efficiently, no matter how complex the task. This makes Spark on Kubernetes a powerful tool for businesses of all sizes, helping them unlock valuable insights from their data.